My name is Lindsey Hartfiel. I am a Ph.D. candidate at Iowa State University in the Department of Agricultural and Biosystems Engineering. Today we are at what we call the UTHI Dual Chamber Bioreactor. It's located about 25 minutes southwest of Ames, Iowa. And as a dual chamber bioreactor, this is essentially just two bioreactors that are connected in parallel. So in the context of Iowa, our bioreactors, they typically intercept our subsurface tile drainage from our row crop fields, and we route the water through the bioreactor, where the bioreactor has a carbon source, typically wood chips, but sometimes some other kind of carbon source, and that acts as a food source for beneficial denitrifying bacteria, and those bacteria then work to convert our nitrate into a harmless nitrogen gas. Typically, these bioreactors have a single chamber, just one inlet structure that we use to control the amount of water entering the bioreactor, and then one outlet control structure that helps to regulate how long that water is in the bioreactor for. As a dual chamber bioreactor, this one actually has three inlet structures. One we call the main inlet that routes the water into two smaller inlet control structures that then set the amount of water going into the two bioreactor chambers. And then there's the two outlet structures as well for the two chambers. So this bioreactor, it was designed using the NRCS design standard. It had a large 14-inch tile coming into the system, but it turns out that the 14-inch tile is actually larger than what the drainage system actually required, and so we had historically had much lower flow rates than we had expected. So we saw complete nitrate removal pretty often at this site. So to add some additional flow, try to get some additional nitrate treatment, we added in this pumping system. As we've monitored this creek here for the past 3 summers now, while we're collecting samples from our bioreactor, and the creek has nitrate concentrations pretty similar to our tile drainage coming into the bioreactor. Okay, so this creek is a big creek, and in the first part of our system is we have a large, pretty coarse filter just to keep large debris out of the system. We opted to not include a smaller, fine filter to keep the sediment out because we felt that the system would probably get clogged pretty frequently and add some strain to our pump. So we did not include that. But from there, it goes into our pump, which is behind us on an elevated platform. Because this site is so close to the creek has flooded and gone out of its banks on top of the bioreactor, so we had to raise our pump up to keep it out of the floodplain. And also inside that box is flow meters that we use to know how much water we're pumping from the creek. Then we have valves to kind of restrict the flow to how much the bioreactor is needing at the particular time that we're using it. And from there it goes into our two separate water control structures for the two inlets. So we have the flow monitoring from the creek up in the box, and then down below us back here there are the two outlets, and those also have flow monitoring in them, so we can figure out, based on what we're pumping from the creek, what we're seeing coming out of the outlet, how much was tile drainage, how much was from the creek, and the main inlet has that tile drainage coming in, so we can see the difference between the two concentrations. We collect our water quality samples weekly at this site as grab samples. So this site also has 9 random sampling wells per bioreactor chamber, and so we can collect samples throughout the length and width of the bioreactor to know what's really going on inside the bioreactor. So we will pump our wells out, make sure we're getting a fresh sample, and then collect samples from there, as well as the inlets and the outlets. So we only recently got to use this pumping system because this year we've had a lot more rain than we've had in the past couple years, and pretty timely rain every week or so. We were getting pretty decent storm events. So we've only recently been using it, and as we're treating a surface water source, the water is a lot warmer than the tile drainage, and also the creek has sediment in it, which has carbon in it. So by pumping the water from the creek, we have higher temperatures and higher carbon, so that really makes our bacteria really happy, and they really like to do their job and convert that nitrate to nitrogen gas. So we saw in the times that we've been using this really rapid denitrification. We have complete nitrate removal in the system, Yeah, we don't want to see complete nitrate removal. We'd like to see a little bit of that nitrate still left in the system, because once the nitrate is gone, it allows for other microbial processes to occur. So one of those is sulfate reduction. That one's linked to methylmercury production in other freshwater systems. And methylmercury is a really harmful water pollutant as well, so we would essentially just be trading our one water quality problem potentially for another. So that's something we'd really like to avoid. Another thing that can happen is we can see methane being produced in these systems as well, which is a greenhouse gas that we'd really just not like to see being produced. Are we concerned about the sediment entering the bioreactor, if that's going to clog the bioreactor up? So it is something we're monitoring for. We did some tracer tests before we started the pumping system this year to see what the flow parameters are like in the bioreactor right now, what its hydraulic properties are, and then we'll monitor again to see if it has changed as a result of sediment entering. There's the two chambers, and chamber B is located at a slightly lower elevation than chamber A. When they installed it, tried to make it level, but in the installation that didn't come out totally to fruition. So chamber B, when there's low flows, gets more water than chamber A. So in chamber A, the past, we've monitored 2019 through now. So looking at 2019 to 2021, we have seen essentially complete nitrate removal when we look at median or average concentrations in chamber A. But chamber B is the one that's been more variable, best performance in its first year, and then it's been getting a little less in terms of nitrate removal over time. I think one of the main things that we hadn't really considered is, as a surface water, it's warmer, it has that higher carbon. So I think that's the biggest thing to really consider in the timing of using the pumping system. If you're trying to select a source, something to consider. While the tiles are flowing, the creek has really good high nitrate concentrations for this purpose, to pump and treat it. But later in the year, as the tiles stop flowing, the creek gets lower and doesn't flow as much. We see lower nitrate concentrations. So selecting a good pumping source is important in it, and then considering the timing of when you're going to be using it. So if you're using surface water, it would be more ideal for early spring or early summer before the water temperature gets really high, especially because it does have that extra carbon that the bacteria like to use. This system, we do have to manually come out here, turn it on, turn it off when we need to. So this one also, we designed it with flexibility because it was the first pumped bioreactor here in Iowa. So we wanted to make it flexible, that we could make adjustments if needed, change it, and that we can take it down for winter so we don't have to deal with components freezing. Yeah, if this would become a proven concept and we'd figure out the best timing to use it, best sources to be pumping, it could become more automated and less of a manual need to turn it on, check it, turn it off when needed. Yeah, the hope with these pumped bioreactor systems is that we can extend the use of bioreactors beyond just subsurface drainage, which is really their only application so far here in Iowa. So some of those could be treatment of surface waters that have high nitrate levels, if we can figure out the timing of that. And then, or something like irrigation waters, or if we're collecting storm runoff that has high nitrate, something like that, where we could treat additional amount of nitrate, because we do have such a high nitrate loading to the Gulf of Mexico, trying to reduce that. Okay, so in these white PVC sampling wells, we also have some wood chip bags that we are keeping in them so that we can monitor how the wood chips are degrading over time. And with this pump system, we believe these sampling, the bioreactor itself could potentially have an extended life, because the pumping system could provide a more consistent, constant flow rate, where these tile drainage systems typically, at this point in the summer, they'll stop flowing and then they can sit dry for a long period where the wood chips can then break down. So if we can keep a more consistent, constant flow to the bioreactor, we do think it has the potential, with the right application, that it could extend bioreactor life. This site, we're gonna continue pumping. We'll probably shut it off here pretty soon this summer, as the nitrate levels are dropping in the creek as well. But if we do get high nitrate concentrations come this fall again, we'll turn it on, use it again. and then we'll see how things are going, but we might turn it on again next year to get another year of data on this particular pumping system.